Every square matrix has associated with it a special quantity called its determinant. Now, determinants turn out to be very useful when it comes to doing more advanced things with matrices, like finding inverse matrices and solving simultaneous equations. And later videos will cover these topics. We're going to, in this video, just look at finding the determinant of a 2 by 2 square matrix. So let's look at an example. Suppose we have a matrix A, which has got entries in it, elements in it, 4, 3, 5, and -1. So this is a 2 by 2 matrix, it's a square matrix. Now the determinant is a single value. It's a value that's generated by combining the numbers within the matrix in a special way. For 2 by 2 matrices, the way isn't particularly hard, but equally it's not particularly obvious that you would do it this way. So we need to just see an example. So we want to find the determinant of A, and we normally denote that by the letters D, E, T, being the first 3 letters of determinant. So we write det of A, and when we're working out determinants, instead of using round brackets around the matrix, we use vertical lines. But the numbers within the vertical lines are exactly the same. And now we have to combine those numbers. The first thing we do is we look at the numbers on the leading diagonal. That's the 4 and the -1. And what we do is we find their product. We multiply them together. So 4 times -1. Now, having dealt with the numbers on the leading diagonal, we've got 2 numbers left, the numbers that aren't on the leading diagonal. And so we multiply those 2 numbers together. So that's 3 times 5. So we've got the product of the numbers on the leading diagonal, and we've got the product of the numbers that are not on the diagonal. And then we just take this second product away from the first product. And then we work it out. 4 times -1 is -4, 3 times 5 is 15, so we take away 15, -4 take away 15 is -19. And so that's how we do every single determinant for a 2 by 2 matrix. We simply find the product of the numbers on the leading diagonal and take away from that the product of the other 2 numbers. So let's do another example. Here's another 2 by 2 matrix B with elements 6, 2, 3 and 5. And to work out the determinant of B, we find the product of the numbers on the leading diagonal, which is 6 and 5, and then we take away the product of the other 2 numbers. The other 2 numbers are 2 and 3, so we're taking away 2 times 3. So 6 times 5 is 30, 2 times 3 is 6, so we've got 30 take away 6, and we're getting 24. Do one more example here. So we've got the matrix D, which has got entries 6, 4, 3 and 2. Now when we work out the determinant of D, we do the product of the numbers on the leading diagonal, which is 6 times 2, and then we take away the product of the other 2 numbers, which is 3 times 4. So 6 times 2 is 12, taking away 3 times 4, which is also 12, and so we get the answer 0. So we see that every time we work out a determinant, what we get is a single number. The determinant of A is -19. The determinant of B is 24. The determinant of D is 0. Now when a matrix has a 0 determinant, it has we give a name to that property. We say that the matrix is singular. So any matrix which is singular is a square matrix whose determinant is 0. These other matrices where the determinant wasn't 0 are called non-singular. So it doesn't matter what the determinant is, just so long as it isn't 0. That makes the matrix non-singular. Finally, we'll just look at a general 2 by 2 matrix. So here we have a matrix A, and the entries, the elements in this matrix are A, B, C and D. So if we want to work out the determinant of A, we just follow the process we've already seen. We take the values that are on the leading diagonal and we multiply them together to get AD. We take the other two values and multiply them together, which are B and C, and we subtract this second product away from the first product. And so this is the general formula for any 2 by 2 matrix. If the elements are A, B, C, D, the determinant is worked out to be A times D minus B times C. So that's all there is to know about the determinants of 2 by 2 matrices.